Nope.
Okay,
So we're going to talk about the properties today, and we're also going to talk about factoring. Now, my other classes talked about the properties, but they did not talk about factoring, okay? So that's going to be kind of like just an advanced thing. So the first property that we're going to talk about is the commutative property. So I would write the name commutative property. Now, the commutative property is only for adding and multiplying. You can only do that when you add or you multiply. You don't have to write out the words. You can just put a plus sign and a multiplication sign. So it doesn't work for subtracting. It doesn't work for dividing. But what the commutative property says is that you can change the order of the digits when you add or change the order of the digits when you multiply, and you're going to end up with the same answer. The reason that I have the CO in red and the change order, the CO and the change order in red, is to help you remember change order, commutative, CO, change order, okay? Changing the order of the digits. So we're going to look at some examples, which I would think that you probably don't need to write down the examples, but, or maybe you want to write down one of the examples. I don't think you need to write down all of the examples, okay? Now, the reason that the commutative property is helpful is because you can more easily add the numbers mentally or multiply the numbers mentally. So, for instance, in this first example, if you were just working from left to right, 5 plus 17 is 22, and then 22 plus 15, that's fine, but it'd be a lot easier if instead you did 5 plus 15. And most of you all do that naturally, correct?
Yeah.
You just do it. So what you're doing in your head is the commutative property. It's not something you necessarily need to show, all right? But you do need to, if I had this, you would need to be like, oh, the commutative property was used there because what she did was switch the orders of the numbers, okay? So being able to identify the property is important, as well as use it. So what's the answer here? 37, because you get your 20 plus your 17, so 37. Now in this one, what would you all add first? What would you add together?
9 plus 1.
The 9 plus the 1, which would give you
10.
10, and then 10 plus 42,
52.
52. What about in this one, what would you add together?
6 and 4.
The 6 plus 4 would give you
10.
plus the 18.
28.
So again, using that commutative property to change the order that you're adding can help speed it up when you're doing it mentally. But you need to be able to look at the two sides of the equation, technically an equation because there's an equal sign, and be like, oh, the commutative property was used because they changed the order of the numbers. Now this works the same way when you have multiplication. So again, if you want to write one of these examples, that's probably all you need to write. Like in this first one, if we didn't switch the order around and we did 9 times 2 is 18 and then 18 times 5, then we could do that, but there's an easier way. It'd be a lot easier to do 2 times 5 and then times 9. Because what's the answer to that? 90. In this second example, what would it be easiest to multiply together?
4 and 5.
All right, some people said 4 and 5. Other people have said 8 and 5. As long as you're multiplying by 5 and one of the other numbers, it'd be good, right? I'm going to say 4 and 5. That's what I heard most people say at first. So that'd give you 20, and then 20 times 8 is
160.
I would do 8 times 5 first.
So we all hopefully know that 20 times 8, you just do your 2 times 8, add on your 0, correct? All right, and this last one, it doesn't really look that bad. 3 times 6 is 18, and 18 times 2. But sometimes people make silly mistakes when they're doing 18 times 2. So it might be easier, and you might make less mistakes if you go ahead and do 3 times 2 is 6. And then, and then 6 times 6 is 36.
How is 3 times 2 5?
Okay, so again, commutative property is changing the order of the numbers so that it's easier to add or easier to multiply. Okay, now the property that people get confused with the commutative property is the next property, which is called the associative property. So go ahead and write that name, associative property. Now the associative property is also only for adding or multiplying. And the purpose, the use of it is the same. It's to make it easier to add or to multiply, usually mentally. But instead of changing the order of the numbers, what you're changing is the grouping. And whenever you're talking about grouping in math, you're talking about some type of grouping symbol. And in this case, you're going to be talking about parentheses. Okay? So we're going to be moving the parentheses, not moving the numbers around, only moving the parentheses. And by moving the parentheses, you're basically changing your order of operations. Okay? Now, I have people try to remember associative property with it's who you're associating with. Have you ever had an adult say you shouldn't associate with somebody?
No.
Yes.
No.
If you've never heard anyone say that, then that probably means you make good decisions on who your friends are. But if you have heard that, like you shouldn't associate with that person, that means you shouldn't hang out with them. Okay? They're not good to be around. They might be a bad influence. You shouldn't associate with them. So when we talk about numbers associating with each other and hanging out, well, that's their group, okay, that grouping symbol. So again, if that helps you. So change order, commutative, grouping, associating, associative. All right. I would not write down anything on this next slide, just look at it. So hopefully you can see that this blue side and the red side, that the numbers on the blue side and the red side are in the same order, 5, 2, 1, and over here, 5, 2, 1. The only thing that changed was where the parentheses are located. So this is an example of the associative property. Because I didn't change the numbers, I only changed the parentheses, which would then, once again, change your order of operations. So, again, I don't think you need to write down every single one of these 5 examples, but you might want to write down one of the addition and one of the multiplication. Now, in this addition example, right now we have 14 plus 8 that are going to be added together, but it'd be a lot easier to add what?
8.
The 8 and the 2 would be a better match. Okay, the 8 and the 2 would be a better match. So if I was going to show the associative property, I would want to leave my 14 first and then have my 8 plus 2 in parentheses. Notice that the order of the digits has to stay the same in order to be using the associative property.
What happens if you mix up the order of the numbers?
Then that means you use both the associative property and the commutative property.
Would that still work?
Not if they're only saying use the associative property. Okay. So what would be the answer here?
24.
24, right? 14 plus 10, 24. And this one, don't you think it'd be easier if we instead put the parentheses around the 51 and the 9?
Yeah.
It'd be easier. So then we'd have 35 listed first, and then your 51 plus 9 in parentheses. So what's your answer to that?
95.
95. 35 plus 60, 95. Oh, sorry, whatever. Okay, works the same way for multiplication, where we can change where the parentheses are located, all right? Again, to help us. So this would be easier as 3 times, parentheses 5 times 2, which would equal 30. This one, now 15 and 4, that's not great, but it's a lot better than 15 times 32, correct?
Mm-hmm.
So 15 times 4, whenever I think of that, I think about time. Why am I thinking about time?
Because that equals 60 seconds in a minute.
15 minutes is a quarter of an hour. 4 15-minute periods would be a whole hour, 60 minutes. So I know that 15 times 4 is 60, and then 60 times 8, 6 times 8, add your 0 to the back of it, right? 480. And then last one here. This one's not too bad if you would leave it the way it is, but it might be easier to do your 19 times 2 and then times 10. It's 308. All right, so in review, because again, commutative and associative, people get them confused. Commutative is changing the order of the numbers. Associative is changing where the parentheses are located. Okay. All right. Next, don't write this yet. Identity property. Now there's a separate identity property for addition and for multiplication. So the identity, your identity is who you are, and you shouldn't change who you are for anyone, right? Really shouldn't. So let's talk about what would happen if you were going to be adding a number. What could we add to 5 without changing its identity?
0.
0. So that is the identity property of addition. So I'll write that. Identity property of addition. It says that you can add a 0 to any number without changing the value of the number. The identity property of addition says that you can add a 0 to any number without changing the value of the number. Now, I know you guys know that already, but it's important for you to know that it's called the identity property. So in all these examples, again, I don't really think you need to write an example. Maybe write 7 plus 0 is 7 if you want an example. But it works whether it's a whole number, a decimal number, a fraction, a negative number, a big number, a small number, doesn't matter. Any number plus 0 is itself.
It only works for addition?
Well, could we say that multiplying by 0? Okay. So it has to be a different property. It has to be identity property of addition is different than the identity property of multiplication. So let's go ahead and say why. In the identity property of multiplication, you could multiply by 1. So that's the identity property of multiplication, okay? It says that you can multiply by 1 without changing the value of the number. Again, I have a few examples here. Doesn't matter if it's a whole number, decimal number, fraction, negative number. Doesn't matter. All right, commutative property, changing the order of the numbers around to add or subtract, or to add or multiply. Associative property, changing where the parentheses are to add or to multiply. The identity property of addition says you can add 0. The identity property of multiplication says you can multiply by 1 without changing the value. Okay, 2 more properties, and then we'll talk about factoring. The next property is pretty easy, and it's only for multiplication. It is called the 0 property. And the 0 property says if you multiply by 0, it's 0. If you multiply any number times 0, the answer is 0. So it doesn't matter if it's a whole number or a decimal or a big number or a small number or a fraction or a negative number. If you multiply by 0, it's gone. Even a variable multiplied by 0 would be 0. All right, so we're about to get into our last property, which is called the distributive property, which I'm sure you did some last year. And then factoring is kind of like the backwards of a distributive property. So that's why I'm teaming it up with the distributive property, okay? Are we ready for a distributive property? Why don't you, I have some slides that I don't want you to write everything down. So the only thing that I'd like for you to really write down right now is just the title. Don't write anything else until I tell you, okay? So just write distributive property. And then we're going to talk about some things, and then I'll tell you when to write an example. Okay, so the distributive property, if we had this expression, now this is called an expression because there's not an equal sign. And if we wanted to simplify this expression, if we use the order of operations, we would do what's inside the parentheses first. 8 plus 3 is 11, and then 4 times 11 is 44. Great, we know how to do that. We could also solve this problem using the distributive property. Now again, don't write all this down. And we would do that by doing 4 times 8 and 4 times 3. So 4 times 8 is 32, 4 times 3 is 12, and then if you add up 32 and 12, you get 44. So the distributive property, you're taking the number on the outside of the parentheses, and you're multiplying each of the terms inside of the parentheses by it. Now, why in the world would you do that for this problem? You wouldn't, okay? This takes more time than doing it the original way, which was just 8 plus 3 is 11, and 4 times 11 is 44. That's easier. So the purpose of the distributive property is for when you have variables, okay? Because when you have variables, still don't write anything down. Remember, this is all posted on Google Classroom, so you can look at it if you need to. I promise it's gonna be okay. In this expression, 4 parentheses m plus 6, we can't do m plus 6. We don't have that option anymore of doing the two numbers inside of the parentheses, so adding them up. Why can you not add m plus 6?
Because we don't know.
Because you don't know what m is. You have no idea what m is, so it's impossible. They're called unlike terms. But what you can do is multiply them both by 4. So 4 times m would be 4m, and 4 times 6 is 24. And then you stop. That's it. That's your answer. Okay? You cannot, once again, you cannot add these two terms because this term has an m and that term does not. All right, so I would like for you to write this first expression. 5 parentheses 2m minus 3. You guys remember doing this last year?
No.
All right, some yeses, some nos. Most people don't really struggle with distributive property, so even if you're a no, don't worry. All right, so we're going to do 5 times 2m. What is 5 times 2m? 10m. Now, my other classes didn't have to worry so much about negative numbers, but I'm going to kind of talk about negative numbers with you all, okay? For right now, we're only going to be distributing positive numbers, but I want you, when you're thinking about this, we're going to do 5 times this 3, but I'd really kind of like for you to think about it as being a negative 3 because of that minus sign. A minus sign and a plus sign mean the same thing. So really think of 5 times negative 3. What's 5 times negative 3?
Negative 15.
Negative 15. And you're done. Okay, so again, 5 times 2m is 10m. 5 times this negative 3 is negative 15. Questions on that one?
What's root of negative?
I want you to think about it as the negatives, because you were at that stage. My other classes have not even talked about negatives yet. Yes?
Because the dog root under the negative.
Yeah. Okay, this next one. 4 times 6w would be 24w. And then I'm going to do 4 times 3. Now this is like a positive 3. Okay, that plus sign means that's a positive 3. So 4 times 3 is a positive 12, right? Because if I just wrote a 12, that doesn't separate my 24w and my 12. I really need that positive sign. And that's it. Don't combine them. Why don't you try this one? All right, so you first should have done 6 times 5v and gotten 30v. So if you got 30v, you're halfway there. Next, you should have done 6 times not just 4, but think of it as being a negative 4. 6 times negative 4 is negative 24. And you're done. Yes?
Would it be possible to make it 6 times negative 5v? Or
Only if it was a negative 5v. So yes, it is possible that you see a problem sometime like that. It's possible that this is a negative 6 out here. Okay? You could have
That's a lot of
negatives anywhere.
negatives.
For right now, no. We're taking this one step at a time. All right, any questions about distributing? Remember, all these notes will be posted. Kimber.
On the second one, for
Yeah.
the positive, do you want us to put the plus in front of the 12 on the Google Doc thing?
Well, this would be like your answers, 24w plus 12.
Okay.
So yes. Because if not, it would just be 24w 12. And you definitely need something separating the w and your 12. Good question. Okay, now, factoring. Factoring is like the backwards of what we just did, all right? Instead of having our answers that we just made, we're going to write the original question. And we're going to do that by factoring out the GCF. Now, we've talked about GCF and the DMR, so hopefully we've kind of reviewed that enough that you could find the GCF just in your head. all right? I kind of like factoring things, but I like math, and you guys like math, so you might like it too. All right, so let's see. Go ahead and write down 40x plus 30. And I want you to be thinking to yourself, the numbers 40 and 30, what is the GCF of 40 and 30? 10. Great. So my GCF is what is going to go on the outside of my parentheses. Okay? 10. So the first thing that I want would be 10 times what would give me 40x? 4x, right? We have to have the x with it. 10 times 4 is 40, so 10 times 4x is 40x. Great. Then, plus, all right, I'm going to have them, you don't have to worry too much about the plus and minus stuff. 10 times what would give me 30? 3. You're done. You just factored. Okay? I want to do a few more examples, but this is it. Questions about what I did here? Yes?
So we want to solve that, we just write that out?
There's no solving now. We're just like simplifying. Well, this is factoring, but yeah. All right, let's look at this one here. 15 and 35. What's the GCF?
15 is 5. Wait, not 15. 5.
5. So 5 is going to be what goes on the outside of the parentheses. 5 times what would give you 15m? 3m. And then plus, yes. 5 times what would give you 35?
7.
You got it. So 5 times 3m is 15m. 5 times 7, 35. Done.
Is there anybody that doesn't enjoy this? Like
Yeah.
in this class or the other?
I don't know. All right, this one here, 16 and 8. 16 and 8. What's the GCF of 16 and 8? 8. 8 times what is 16w? 2. Don't forget your variables, okay? 2w. Plus.
1.
Oh, I didn't trick anybody. 8 times what is 8? 1. You have to have that 1 there. Okay, you have to have the 1 there. Very good. Almost done. Almost done.
You said that we
I'm
want
sorry?
quick.
Would you be like subtraction?
But it's not going to change. It's not going to affect how you're doing this. Okay. 12 and 18. GCF is 6. 6 times what is 12y? 2y.
Minus.
Just put in your subtraction sign. Don't even think about it. Okay? I mean, pay attention that it's subtraction, but it's not going to affect how you do this. 6 times what is 18? 3. And you're done.
This is fun.
Try that one on your own. Try that one on your own. Make sure you're using the greatest common factor and not just a common factor. See if I can catch anyone with that. So some people may have said that they're going to put a 4 out front. But if you would have put a 4 out front, inside you would have had a 10 and an 8, which that's not enough factoring. The GCF of 40 and 16 is 8. Okay, so be careful to make sure it's the GCF and not just a common factor. So inside should be what? 5x minus 2. Excellent. And I always like kind of checking myself. 8 times 5x is 40x. 8 times 2 is 16. Good. That's it. Okay.